Okay, guys, these will be your video notes for proportional and non-proportional relationships. It starts on slide 11, and it goes through slide 16. We're going to skip around a little bit. I'll tell you how to make adjustments to your notebook at a later date, but you have a couple of options. Some of this has already been filled in for you on your digital notebook. You can do them digitally. I went ahead and printed them so I could write directly on these because that was going to be easier for me when I was making the video for you guys. So either way, eventually you're just going to have these notes down. So if you want to print them, if you want to write them, if you want to do text boxes and the draw tool, it's completely up to you. I'm going to leave that up to you about how you want to handle doing that. The important thing to me is that you can make the differentiation between a proportional relationship and a non-proportional relationship. And hopefully after this video today, you will be able to do that. So proportional relationships represent a constant rate of change. So the change in y over the change in x is constant throughout our table. Two things are going to be true about a graph that is proportional. The graph will be in a straight line, and the graph will pass through the origin, which we know to mean that the graph is going to pass through point 0, 0. Okay? In a table, we want to check for equivalent ratios. In other words, in a proportional table, the ratio of y over x will always be constant. Okay? So we are going to use this information to fill out, and this is, guys, this is the representation just like we talked about before. We are going to represent the constant rate of change in a table, in a graph, in an equation, in a verbal description, and then we will determine if, how and why it's proportional or why it's not proportional. Okay, so let's look at this information on number 1. The number of miles a white-tailed deer travels is shown in the table below. So right here, complete the missing information. Okay, if I know, because there are things that are missing, here's my hours, here's my miles, so I can use what I have here in order to figure out what's going on in these other boxes. So really, I'm looking for a unit rate. If I know in 3 hours that they travel 84 miles, I need to know how many they travel in 1 hour. So to get from 3 to 1, I could divide by 3. But I have to do the same thing on this side. So 84 divided by 3 is going to be 28. And once I get there, I can pretty easily figure out what 2 is. I'm just going to double 28. So in 2 hours, I can travel 56 miles. Okay, so I'm adding 28 every time is what it seems like right now. So 84 plus 28 is going to be 112. And then 112 plus 28 is going to be 140. 140 plus 28 will be 168. Okay. In 7 hours, I can travel 196 miles. In 8 hours, I can travel 224 miles. And I'm getting that because I'm adding 28 every time. So in 9 hours, I can travel 252 miles. Okay. This is the part where it's going to get a little complicated. I'm going to use the information here to do my graph. Okay. So if this is true, this is my x and this is my y, because the number of miles I'm traveling is dependent on the number of hours. Okay, so this is my x, this is my y, this down here will be my hours, and on my y-axis, this will be my miles. Okay, so for our scale, we're going to do 1, 2, 3, 4, 6, 7, 8, 9 hours. Okay. And then over here, because we go all the way from 28 to 252, it might be easy for us to do increments of 30 or increments of 20 whichever one that you prefer. So let's do, I'm going to do 30. So 30, 60, 90, 120, 150, 180, 210, 240, and 270. Okay, so on my first hour, I can travel 28 miles. So I'm going to put that about right here. Okay, that also means that in 2 hours, I can travel at about 56 miles. In 3 hours, at about 84. In 4 hours, at about 112. And again, I'm just estimating this. In 5 hours, I can travel 140. In 6 hours, 168. So that would be somewhere around here. In 7 hours, 196. So that would be somewhere around here. In 8 hours, 224. So somewhere around here. And in 9 hours, 252. So somewhere around here. If I were to use a ruler or the straight edge of my paper, I could draw a line, and it would be a straight line through my graph, okay? This also should tell me, guys, if I'm thinking about reasonableness in terms of mathematics, that for my equation, or not for my equation, I'm sorry, I know that in 0 hours, I'm not going anywhere. So is my current line passing through my origin? Yes. Okay, that's going to be important as we come and talk about the proportionality part in a second. So for my equation, let's talk about what's happening. Y equals, well, in order to figure out what my equation might be, I am going to go and I'm going to look for the rate of change. Okay, so let's talk about the rate of change. Let's go back and look at the graph. So for rate of change, it's going to be my change in Y over my change in X. Okay, well, to get from 28 to 56, we added 28. And to get from 1 to 2, we added 1. So my change in Y is 28 over my change in X, which was 1, which makes my rate of change equal 28. Oops, sorry, I didn't move it over again. My change in Y, let me explain that because I think I was out of the frame. Okay, so on my Y, from 28 to 56, I was adding 28. For my X, from 1 to 2, I added 1. And in order to find the rate of change, it's my change in Y over my change in X. Well, my change in Y was 28. My change in X was 1. So 28 divided by 1 is 28. So remember, I represent that right here. It's going to be my coefficient. 28 times my X is going to give me Y. So let's plug in a value. Okay, 28 times 1 will give me my Y value of 28. Okay, 28 times 2, if I plug in 2 for my X, 28 times 2 is 56, which is my Y value here. So my equation would be Y equals 28X. Okay, the next part that we're going to work on is a verbal description. Well, we know we're talking about a deer, and we know that it's traveling a certain mile per hour. So we would say a white-tailed deer travels 28 miles per hour. And that would be our verbal description. You could say a white deer travels at a rate of 28 miles per hour. Okay, so now we need to look at our last box. Our last box tells us if it's going to be proportional or not. So let's talk about the proportional. Did it go through the origin? Yes, it did. Does it have a constant rate of change? Yes, the rate of change is equal to 28. It's a constant rate of change throughout. Okay? And it is also, in my graph, a straight line. For all of those reasons, this is a proportional situation. It is a proportional relationship. Okay, I'm sitting at about 10 minutes. So what I would like to do is to keep going. Okay, I'm going to go on to the next slide, which should be, and I think my printer didn't print it out here. That's my bad. This will be slide 11. Slide 11. Okay, and again, let me zoom out a little bit so I can get all 4 of them together. Right now, it gives us a verbal description, and from that verbal description, we're going to have to come up with our graph, our equation, and our table. Okay, so for our verbal description, it says the student council is selling t-shirts to raise awareness for the local animal shelter. For each t-shirt they sell, they will donate $7. So this is going to be the t-shirts that are being sold, and this is going to be the amount of money that they are selling for. Okay, so it says for each t-shirt, it's going to cost $7. So if I have 5 t-shirts at $7 each, that's going to be $35. If I have 10 t-shirts at $7 each, that's going to be $70. Okay, 15 t-shirts at $75 each, or at $7 each, I'm sorry, is going to be $105. And you can either include those decimals or you can not include those decimals. That is completely up to you. These are your notes, but we are talking about money, so it might be helpful to include those decimals. Okay, 20 times $7 is $140. 25 times 7 is $175. 30 times 7 is $210. 35 times 7 is $245. 40 times 7 is $280. And 45 times 7 is $315. Okay, now that we have our table, we can use that information over here in our graph. So our t-shirts are going to be our X, and our money is going to be our Y. So you can go ahead and label that. This is going to be our X. This is going to be our Y. This is our number of shirts. And this is going to be the money that each shirt cost. Or not the each shirt, the total that each shirt cost. The total donated. Let's put that because that's what goes with our situation. Our situation said that they are raising awareness for the animal shelter and they will donate $7. So this is the total amount of money donated. Okay. So down here, we can use increments of 5 because that's what happened in our table. And it's okay if the whole thing doesn't fit. We're just trying to get the idea. Okay, and then on this side, it might be helpful to do increments of 30 or increments of 40, since we go anywhere from 35 to 315, or we could do increments of 35 if we wanted to. So we could say 35, 70, 105, 140, 175, 210, 245, 280, and 315. Okay, then we're just going to make the points in our graph. So we have 5 and 35, 10 and 70, 15 and 105. Oh, Miss Brown wrote 15 twice. My bad. 20, 25, 30, 35, 40, 45. Okay, so 20 and 140, and so on, guys. All right, so if we were going to draw our straight line, that would definitely be a straight line in a graph. And guys, I'm at 14 minutes and 40 seconds, so it's going to cut me off. So I'm going to go ahead and stop this and make a second video.